Alright, let's get started. So, to begin with, the first thing you need is some prerequisites. We need to have Microsoft SQL Server installed and also a database management system. We do have Azure Data Studio right here, which is one of the options. We also have DBeaver, which is another option, and SQL Server Management Studio at the bottom, which is another option. So I'm going to click on SQL Server Management Studio to get started. We installed it. It's plain and simple, clean, no database installed or nothing at all, just the server. So we can connect to the server and check it out. If we check out the server or database, we just have a simple database we created for 10 days or 100 days IT challenge. No tables in there, looks squeaky clean. The test database also has no tables. Actually, we do have some tables that we migrated from our DBeaver. So let's go back to DBeaver and take a look. Open it up. When we installed DBeaver, we did accept that we wanted to have some sample data installed with it. For Azure Data Studio and SSMS, we did not install any sample data. So the tip of the day is shared with us. We're good with that. If we expand this SQLite database, sample database, we can see the tables. So it did come in with all of these tables. Now, as a database architect, you need to create the data model which actually describes what's in this table. For us to be able to see what this data model is, which is created using data definition language, we can right-click on this tables folder. So while clicking on that tables folder, we should be able to see an option that says view diagram. That is the entity relationship diagram. So let's take a look at it. This is what an entity relationship diagram or an AR diagram looks like. We can zoom in and out to make it clearer. You can see all the tables. The name of the table is at the top. It looks more or less like a class diagram. Okay, every object is an entity of a class, or an instance rather, of a class. So a class diagram usually has the name of the object at the top and the name of the attributes inside. So the attributes in this case are columns. These are our columns. They have data types and the names of the table. So an employee table has an employee ID. This employee ID is the primary key. The customer table has a customer ID, which is also a primary key. You can see a tiny key icon in there. You notice that all of them have primary keys. The primary keys are usually numeric. Okay, they're IDs. So somehow we have a connection. This is what makes it a relational database. There's a relationship between the employee and the customer. If you right click on that, oopsie, you can get more information about that particular. I don't want to arrange the diagram. You can get, just click on it rather. You can get more information about that particular employee. So the employee is connected to the customer by the support rep ID. So the name is different, but it's the same. Just like the customer ID is a foreign key in the invoice table. Right there, you can see how it's related. And the invoice does have the invoice ID in the invoice line, and so on and so forth. So that is how our table is set up. Now, there's one table in here that's not connected to any of them. That's just information about the schema. It's more or less like a data dictionary. You can always open that separately. Right here, you see it's located right there as well. And it just lists out all the tables in there. So let's go ahead and open that up by clicking on it and viewing the table. If you view the table, you can see the different columns, the data types, the lengths, and if there are any default values, which there's none. We're now looking at the properties of the SQLite Schema table. We can also check out the data. In there, you can see all the tables and the indices. 22 in total, about 11 tables and 11 indices. It gives you the name of the table and the name that is saved in the system. Okay, the system name and the common name that we use. Also, it tells you any web pages and so on. But more importantly, it shows you the SQL query. If you click on it, it should display in the values, which doesn't because I closed that up, but you can get the panel out there. But that is the query that is used to create each one of those tables. There's an easier way of fetching that information, which I'll show you shortly. Again, the AR diagram in this case is going to show just the table. Now, from the SQL Schema tab, let's go back to our entity relationship diagram. So looking at what we discussed, we saw in the SSMS tool, we had 100 days IT challenge. We can get some of this information here so that we don't have to start from scratch to build something similar in structure. We don't need employees, we don't need customers, we don't need invoice and invoice line for now, but we can set it up so that we have artist album track to be something like the trainer, the series, the session, and we can also create playlists out of there. This is a many-to-many relationship with a table that is actually acting as an intermediary between the two of them because it's a many-to-many relationship. One track can be found in many playlists, and one playlist could have many tracks. We also have genres, media types, and so on. So we can replicate this 2, 4, 6, 7 tables in SSMS. I'm going to switch over to SSMS to show you what I mean. So these are the tables that have been replicated here. I'm going to do the same thing, not in the test database, but in the 100 days database. So let's switch back to DBeaver. So again, DDL is the definition language that is used to create these tables after the architect has already sat down, brought up the concept, the logic, and the physical model of what the database for our particular project or system should look like. So we need to set up an artist, album, track table. To get those, let's start with the artist table. Right here again, we'll use the power of right-clicking. You can right-click and maybe just view the data to begin with. We click on view data, you can see that there is more than 200 records. It's fetched just 200 so far. You can scroll down and see there is more that is being generated as we keep scrolling. And we got all the way to 275. Luckily enough, there are not that many. Most databases in corporate world are enormous. Okay, so we've taken a look at that. We can shut that down or close that table and right click to actually show what I wanted to point out. There's so many options to look at. Take your time and go through each one of them. We don't need to check out the diagram. The one I want you to actually pay attention to is generate SQL. For generate SQL, we can generate a SQL to select that data automatically, insert, update, delete, merge, which we already talked about, and DDL, which is what we're talking about right now. So clicking on that DDL actually shows you how this database was created. It is known as the artist definition database. You can see that the create keyword is used, the table keyword is used, the name of the table that needs to be created, artist, and in parentheses you have the columns and constraints. Just 2 columns are needed, artist ID, the data type is an integer, and the constraint says it is not null, meaning you cannot accept blank values. You must always have a value, or in other words, this is a required field. The name takes variable number of characters. It uses Unicode encryption, so you could probably use different characters if you need, and it allows all the way to 120 characters for the name of the artist. Maybe the name of the artist could be blank, so it does allow a null because you don't have the not null constraint on there. Not very good. Maybe it's something we need to fix with another type of language. The constraint, we want the primary key to be tied to the artist ID, and that's about it. So that is data definition language. With that, we've been able to create a model for our data. You know, we can use this to migrate this structure to another schema or to another database, or to something completely different. Okay, and we also use it for fine-tuning. Let me show you how we can use it for performance tuning. If we check out, for instance, the album, right clicking on the album, generate SQL, DDL, you can see that in this case we created our table called album with the respective columns, 3 of them this time around, added a constraint, primary key, also added a foreign key, and made sure that we have referential integrity so that if we delete a record that has a foreign key somewhere else, it should be also deleted. So on delete, opposite. On delete, no action. On update, no action. So if we delete or update that foreign key or primary key, no action should be taken. That is the rationale with this particular database. Now for performance tuning, we created an index. We gave the name of the index. It's a naming convention in this case. Index, foreign key, album artist ID on album, column artist ID. So we can always go ahead and copy this, DDLs to another database, to another location to create those tables. So I'll go ahead and copy this, and I'll switch over to SSMS. On the 100 days database, I'll right click and create a new query. The new query opens up in the space, and once it's done, it looks really huge and nice. I'm going to insert it by using Ctrl V on my keyboard. So this is what it looks like. We have an album definition, which is commented out so that we can understand what this piece of code does. We can collapse this section. It ends with a semicolon to tell us that's one instruction within this block. So one thing you'll see is SSMS and all the other tools, they'll help you out with stuff like underline. It's screaming out to us that, hey, I don't know what artist is. So what do we need to do? We need to create a table called artist before we can create a table called album. So let's switch back to DBeaver, and we have our artist that we did not create yet in SSMS. So let's go ahead, right click on artist, go into our DDL and copy this over simply. It's now copied. Going back to SSMS, somewhere at the top we can right click and paste it, and now all of a sudden the red squiggly is gone. Let's make this a little bit smaller. Alright, it's always useful to add line numbers to your code, because if you're going to communicate, or maybe you have an error message, it's going to tell you, hey, there's an error on line 20. Right now we cannot see what line 20 is. On the top right there is a quick launch. If you don't know how to get to the line numbers, it's always useful to go in here and ask any question. This is true for most Microsoft products, so make sure you use that. If you go ahead and just type in line number, it automatically shows you where you should go to. So clicking on this will take you directly to that location. But I know that you can go to it from tools, options, and so on and so forth. That's going to take a long time. So for peace of mind, go ahead, line number, click on that. It tells you it's gone to options, gone through your text editor. For all languages in general, we want to show our line numbers. So if I check that on, you should be able to see line numbers in there. That will help us. Okay, now we have line numbers. If we have an error on line 20, I should be able to easily identify it. So we're good to go. Just like that, we can create those two tables. How do we create them? We just execute this query and we're good to go. But we need more tables than that. We also need the track, the genre, the media type, the playlist track, and the playlist. So let's get those real quick and watch me do it. Very easy, as we've done it the first time. Should be straightforward. Come in here and paste that. The track looks good. It's yelling out it needs a genre and a media type. So before we go ahead with the track, let's make some room. We're going to add a genre on line 24. Let's get the genre. Right click, generate SQL, DDL, copy, move back, and that is no longer an error. We go on to the next line, 33. We need media type this time around. Right click, and so on. Copy this and paste. So we don't have any errors any longer. Everything looks good. Let me make sure my spaces are consistent and good to go. We created indices for each one of them: album, genre, media type. So we have how many tables so far? 2, 4, 5 tables. We need a playlist track and a playlist. Let's start with the playlist. Playlist. We need your DDL, please, provided to us. We copy that and paste it right here. So imagine you have 100 tables or 200 tables. That would be very tedious to get all of that done. So most of the time you might need to just export, import, or do a backup from one location and restore it in another location. So here we are. We have everything in place: playlist track definition, playlist definition, track definition, media type definition, genre definition, album definition, and artist definition. Notice that the names of the tables do not have a schema appended to it. If I had a schema created before this, I'll be able to append my schema, but every database has a default schema, which is DBO. So if I execute this now, it's going to create all of this, and it should be somewhere within my tables folder. but it will have DBO in the beginning to notify that is the database owner that created those tables. So let's execute that. In here, I selected that, execute this, showing up, and boom. And just like that, in less than 1 second, our record has been done. But we do not see it under the tables. That's totally fine. That's because it got executed after we loaded this column. So we can go up here and right click to refresh this folder, or select right here and refresh the entire server. If it's a huge database, we probably don't want to do that. If it's a huge server, we don't want to do that. So let's focus on just the tables. Also, you don't need to be moving your mouse all over the place. You can simply right click and select refresh. So we refresh that, and voila, we have our tables now created for us to use. Alternatively, we could have downloaded a copy online. As you see, this is the downloads that we got for AdventureWorks OLTP install script. So there's about 72 items. These are all the different tables for AdventureWorks. It also has SQL query in there. In order for us to install that, we just need to follow the instructions. So how do we do that? Let me go ahead and go to the file menu on SSMS, open, and I'll have to locate that file in my downloads folder. So in my downloads folder, I should see AdventureWorks folder, and I do not see any scripts in there. That's not good. Never mind. That's because I wanted to open a folder. That's not what I needed. Let's cancel that. So file, open, not folder. I need to open a file. So let's select file. In there, we want to go to AdventureWorks. And here are all the files in there, the 72 files. We don't need these Excel files. These are all Excel files, but I do have OpenOffice Calc, which is the icon you see there. So this shows you it is a SQL source file. We want to open that. Once we open it, it gives us some good instructions, tells us what it does, you know, what it can be used for, the dates, and so on and so forth. All that information, once we follow all these steps to run the script, enabling full text search, you know, making sure that SQL command mode is enabled as well. You have to go to the query option here, and here's the SQL command mode. Right now it's disabled. If you click on it, this toggle option is going to show up, and now it should be good. To run your script, you need to just move the folder to that location or change the file path, and it should be, or data path, and it should be good. So like I said, similar to everything we did there, it's going to do a lot of housekeeping, make sure everything is good, and then it's going to drop the database if it does exist already. If it doesn't exist, then it's going to go ahead within the master, run a few things, and so on and so forth. But if you scroll down, it's quite a long file. You'll be able to see the same thing is being done. It creates the databases, creates a trigger, which is an advanced topic we didn't discuss yet, and so on. So very similar to what we just did, but this is a bigger database, as you see, over 70 tables that I will do separately without having a video. But if you need me to do a video for this, let me know and we should be good. So we do have that. Let me close this. We have run our query, we have our tables set up, and we're good to go. We can go ahead and modify these tables or modify the objects very easily as well. And we just have to make sure that everything works correctly. If we're going to modify the name of the objects, we want to make sure that our relationships are not messed up as well. If you're going to rename any columns, you want to make sure that the columns are not affected. So to rename, it's very simple. Let's take, for instance, the artist. Let's change the artist to trainer. So to do that, let's start a new query. Once the new query is started, we want to make sure that we are in the right database. We are in a 100 days database. So how do we rename that? We use the rename keyword. Okay. How do we alter a table? We use an alter keyword, but the alter is going to be used for modifying, adding, or deleting columns. We don't want to delete any columns in here. If we needed to delete columns, then that's what we'll do. Okay. If you don't want to do any of those, you can always right click. Once you right click, there are many ways that you can create scripts for. You can either create a new copy, drop the table altogether, drop and create somewhere else, select, insert, update, which we're going to look at in a separate video. Now, if we wanted to do DDL functions, you can see some of them down here. If we need to rename artists, we can simply click on that, and instead of artist, we can now rename it to trainer, or let's use the more universal word, teacher or instructor, and hit enter. All of a sudden the table is now renamed. We can also go ahead and rename this. Instead of artist ID, it can now become teacher ID. And we're good to go. Now if we need to delete any tables, we can use the drop keyword, or we can also right click on that and, like I said, go into the script to drop the table. Alright, but we don't want to do that right now. Deleting is different from dropping. Deleting is going to delete the contents of the table. Dropping is going to delete both the contents and the structure. Alright, so we've been able to do a few things with DDL. We also defined data integrity by adding constraints, as you saw in our query. Here's an example of a constraint that was added. We also set primary and foreign keys. As you can see, here's a foreign key that was set, and here is a primary key. Alright, so that's it about DDL. A few things we pointed out: used for data modeling, schema migration, performance tuning, and data cleanup, which we are not going to do yet because we don't want to mess up our tables. So everything looks good to go. If you have any questions, please drop them down there. I'll be waiting for you, and I'll be responding to each one of your questions. Enjoy, and we'll carry on with the next sub-language in SQL.